So once again, apply those rules now to these. First thing you need to be careful about is these are not all in general form. The bottom ones are. General form basically means it's simplified, everything's on the left. So the top two are not. If they were, if you move this over, the x squared would become positive, wouldn't it? So that's a circle, in fact. What's the next one? Because it would become a plus 4y squared, and they're the same sign then, but not the same number, so yes, an ellipse. Next one? Parabola. You have x squared but not y squared, so it's a parabola. Next one? Hyperbola, which we haven't done yet, but you should know that's a hyperbola. Next one? Good. And? Another parabola. Be careful once again. You get to where you just start looking at these first two numbers, but the reality is they could be anywhere. They might not actually be in order. And that might not be a y squared term after all, right? So this one looks a whole lot like this one, but this is a circle, this one's not, because that's not y squared. It is a parabola, like you said, so like to be careful. Now, we jump to these. So on all these, we're going to do this one, but you should be able to identify all these. That's the first step. All right, this one, what is it, first of all? It's an ellipse because it has 4x squared plus 1y squared. The coefficients are not the same, but the same sign, so yes, an ellipse. Which means we need to get in the standard form for an ellipse. So we're going to group the x's together, factoring out the coefficient. So the last example on your note sheet, if you haven't done it. And then group the y's together. Move the constant to the other side. Make sure you put a plus 3 there, right? The 3 changes the sign when you move it over. And then here, that becomes x plus 3 squared. Don't forget, I'd put the plus 4 there, and then not plus, but put the 4 there so you don't forget, like I did earlier. And then a 9 is the missing number to complete the square, but we don't put a 9 here. Over here, we put 9 what? I mean, what here instead of 9? Yeah, I'm going too fast. 36. Because once again, we have to keep it balanced. The 9 we added was really inside parentheses where everything's quadrupled. So be careful about that. One little mistake is going to throw everything off. And then this is easy because, you know, half of 10 is 5, 5 squared is 25. And there is no coefficient out here to multiply by, so you really do add 25 to the right on that one. And then this adds up to what? Good. Now we're almost there. You need to change the right-hand number into a 1 by dividing by 64 all the way across. Because once again, we knew at the outset we're going for an ellipse, and standard form for an ellipse has a 1 there. And there you have it. This is x squared, x plus 3 squared over 16, y minus 5 squared over 64. And there's a standard form. Once again, we were given general form, pretty much. It wasn't quite in order, but that's general form. We want a standard form for our ellipse. We're supposed to get parametrics, but I'm going to graph the thing first, and then we'll go back and do the parametric equations. Where's the center? Good. And then a is 8, because once again, a squared is the bigger of the two denominators. So a is 8, b is 4, because it's the other denominator. We need to find c. I want to get the foci graph on this. So we need to find c using Pythagorean theorem once again. C squared, and remember a is the biggest of these three lengths. And so it goes like this. Because a is the biggest. If you want to find c, you're subtracting like that. Well, a squared was 64, b squared was 16. So you get, when you subtract, you get 48. So c works out to be square root of 48. Which is 4 radical 3 if you simplify it. Right, just for the record, that's 16 to 3, which is where the 4 radical 3 came from. All right, let's draw this thing. Negative 3, 5 is here. Once again, A means the distance from the center to the vertex, and it's vertical because it came from under the Y. So you go 8 below and 8 above the center. 8 below is there. 8 above, you just have to estimate, it's like maybe there. And once again, those are your vertices, otherwise known as the endpoints of the major axis. B goes the other way, takes you to the endpoint of the minor axis. So you go 4 left and right. And you can draw your ellipse now. And listen, we didn't really calculate the x-intercepts and y-intercepts. The point I make is, I don't know, maybe that goes to the origin. Probably not. I'm not really concerned about that. That'll be a good thing to do, just to calculate the intercepts, but we didn't. We're not going to bother. I want the foci on there, on the graph, and I want to write the coordinates down. So, once again, if the foci are this distance above and below the center, and then on the major axis, along with the vertices, they're always in the same axis as the vertices. Now, it's kind of hard to know what that is, but it came from this, so it's really almost 7. Sort of 48 is almost 7, right? So it goes 6 point something above the center. Actually, I'll go below first. This is 8, so that's 7, so 6 is almost 7. That's one focus. And you're going to just put this one up here. Guesstimate. There's your foci. And the coordinates, if I write them down exactly, are once again, it's in line with the center, so it's the same x value. And the y value is this much more than the y value for the center. So we write it as 5 increased by 4 radical 3. And this one, if I write the exact coordinates for that point, are on the same vertical line. And then it's the center minus that distance. That's how you write the exact answer if they ask for the foci. But I want to think this through. We said that 4 radical 3 is the same as sort of 48, so it's almost 7, 6 point something, right? So if you do 5 plus 6 point something, you get 11 point something. So this point up here is 11 point something. The top, by the way, was at 5 plus 8 was at 13. So it's 11 point something, almost 12 is close to 13. That makes sense. 5 minus 6 point something is negative 1 point something, almost negative 2, which is where we put the other focus. Okay, so you should have be able to kind of estimate the coordinates, kind of make sure this makes sense. All right, parametric equations. Once again, we always write as x equals y equals. For a circle or ellipse, actually, let me get the coefficients first. A was vertical, so it goes in the y equals equation. B was horizontal, so it goes as coefficient in the x equals equation, automatically, always. Cosine and sine can go whichever way you want. Normally, we expect them to be like this. They don't have to be, which is weird, but it's true. Like the 4 has to be there, the 8 has to be there. The center is at negative 3, 5, so put minus 3 here and put plus 5 here. And those equations form the shape. What I'm saying is if I swap, I have to keep the numbers as they are, but if I swap the sine and cosine, then I get the same shape with a different starting point and direction. I could even make these coefficients positive or negative, and it won't change the shape. Which actually, just to change it up, I'm going to do that. I'll make this one a negative 8, actually. Okay, so change it, make sure you have the exact these parametrics, because now I'm going to do the starting point and direction based on these parametric equations. And starting point always just means when t equals 0. So at t equals 0, Zoe, what's cosine of 0? Right? So when t is 0, this works out to 1 times 4 is 4, minus 3 is 1 for the x value. When t equals 0, sine is 0, so that's just 0 plus 5 is 5. So it starts at 1,5. This is their starting point then. Now, for direction, when I say direction, I mean, which way are you traveling around the shape as t increases? So once you figure out the starting point, pick a new t value that's bigger than 0. Pi over 2 is a nice number to use. Okay? Pick whatever you want, but I'm going to use pi over 2. I wouldn't use pi, by the way. Because, frankly, it's probably going to be over here, and you have no sense whether it went up to get there or down, right? So don't pick something too big. All right, now at pi over 2, cosine is 0, so you get negative 3 for the x value. Sine is 1, so you get negative 8 plus 5 with actually also negative 3. So that means we're here. Negative 3 is here at time pi over 2. But that means our direction of travel is clockwise and around that shape. Okay? And like I said, if you play around with this, you'll find there is a pattern. You can get to where you predict, based on whether it's sine and cosine, where sine and cosine are, and whether you have positive or negative coefficients, you can figure out, so you just know starting point direction automatically. But frankly, we're probably not going to have time to get there. So just plug in 0 and plug in something bigger than 0, figure out your starting point direction. Yes, ma'am? Just for fun. And seriously, the normal answer, the easy answer, is to make these both positive, put cosine there, sine there. So if you're asked to write parametrics, do it that way, then it's easy. If you do it that way, look, I'm telling you, it is, if you do a positive, like I described, you'll always start here and then always go the normal direction around the unit circle, just like you're on the unit circle. If you make it, like I said, where it's cosine and then sine with positive, then it'll be just like on the unit circle. If you want to do it that way, and all the ones where you have to write parametrics, do it the easy way, that's fine. But when you're doing the problems on the homework, they're not all written that way. They swap sine and cosine around. So just like I said, plug it in. The ones in the homework are kind of boring because that's all they do. They don't put any negative coefficients. I don't think they even move the center. I think the center is the origin all the time, which is sad. So, all right. Look at the homework packet. I was going to go over a few of those. On this first section, by the way, which is the first parabola you run into? Yeah, good. I want to do that one, okay? Listen, tomorrow we're going to have a quiz. The quiz will not include parabolas. It's just circles and ellipses, I'll just tell you. The test, of course, will include everything, so you make sure you're keeping your skills up. This one is a parabola. Now, look, it's really helpful, I think, to figure out like what form you're after. It has x squared, not y squared, right? So really the form we're after is the one that has x squared, like x minus 8 squared on one side of the parabola equation, and y minus k is not squared. And, they put the coefficient in front of the n squared term. That's how we do parabolas. So let me rearrange this. I'll keep the x's together. I'm going to complete the square of the x's. Move all non-x terms to the other side. Okay? And then this is x minus 4 squared. What goes here? You can get the square. And of course, you add 16 to both sides. That's 56. And just one more step, really. Factor out the 8. You get 8 times y plus 7. And you're done. And frankly, I'll take it like this. The book writes it that way. I prefer it the way I showed this, with the square term on the right. But it doesn't really matter, the same equation. Okay? And we're done. That was all we had to do, is get it in the standard form. Okay. So, like on these two steps, identify the shape, and then figure out what form you're after before you start the algebra. Now, going forward, I did one like that. Here, look, finding this one, number 14. That's for eccentricity. What was the formula for eccentricity? That's the easy little ratio. Listen, that is the formula for all conics. In fact, I meant to show you. Let me go back to the notes. Where'd it go? Look at this. And so, just to kind of give you a clue, a circle has an eccentricity of 0. All circles have an eccentricity of 0. All parabolas have an eccentricity of 1. And ellipse is somewhere between those. And so the closer to 0 it is, the more circular the ellipse is going to look. And then the closer one is, well, the more elongated the ellipse is. Hyperbolas, by the way, the definition we just said is C over A. That's always eccentricity. Well, in a hyperbola, C is bigger, so a hyperbola, the eccentricity is always more than 1. That's the main thing you need to know. On a circle, it's always less than 1. An ellipse is always less than 1. On a hyperbola, it's always more than 1. So you can see some examples. Like I said, the one where it's exactly 1 is a parabola. There's some various ellipses. The one with the smallest eccentricity is the most circular. So anyway, here. So let's just do this one. It asks for the eccentricity, so we need to find C and A. Actually, I'll do A squared first this time. The others, A squared is 72. I mean, they gave you that's right there, because A is the bigger denominator. So A is the square root of 72, which, just real quick, 72 is 36 doubled. So you get 6 radical 2. Hooray. Now, we need C. Now, once again, they're related like this. A squared, B squared, and C squared are related like that, with A being the biggest. So I want you to realize, you didn't have to figure out what B was, because we just need B squared, which is sitting right there. So 72 minus 54. What is that? Yeah. So C is the square root of 18, which is like 9 times 2, 3 radical 2, it turns out to be. So the eccentricity of this ellipse is 3 radical 2 over 6 radical 2, which works out to what? Those cancel, yes, but you get 1 over 2. There you go. Just do C over A, but make sure you give a simplified answer on those, all right? All right. Let's do one of these. These should be really easy. I say should be, but people make a little mistake, so I just want to go over one. This is an ellipse. So standard form for an ellipse looks like this. You have x minus something squared here. By the way, the center is at 1, 3, so it's x minus 1 squared there, y minus 3 squared there. What goes between? And that seems trivial, but if you leave it out, you're wrong. If you put a minus, you're wrong. It's hyperbola. So make sure you don't forget to put a plus sign there. And always what goes over here? So what people tend to do is they forget to put exponents, they forget to put a plus sign. It's wrong then. If you leave the exponents off, it's not an ellipse. If you leave one of them off, it's parabola. If you leave both of them off, it's a line. So don't forget the exponents. Don't forget the plus sign. Don't forget it equals 1. Now, A is 4, so we're going to put 4 squared. Under the x or under the y? Under the x. It was a horizontal distance, so put A squared there. B is 1, so B squared is 1. And there you go. There you're done. Now, I would take that. In reality, we don't put it down there 1 when we write our final answer. So I'd rather you erase it on there and just write it like that. So I don't think I'll take off. I'll keep on putting it on there 4. Okay? Like I said, it should be easy. Just don't leave out any details. Anyway, all right. One more thing. I'm not going over any of these. This was not in the notes, though. It's not that bad, really. It's a little different from everything else. But all you need to do, if you ever want to find where two graphs cross, you essentially have a system of equations that you're going to solve. We're going to solve by substitution. So I'm going to substitute this in place of y, because it says I can. Now, let me just write that out. That becomes x minus 8 plus 5. I just replaced y with x minus 8, which gives you x minus 3. Now, the nice thing is now everything's in terms of x's, but now we have to solve this equation. I'm going to simplify this first. Josh, what do I get when I multiply that out? X squared, then what? And don't say plus 49. It's minus something first. Anybody? Because the formula is a squared minus 2ab, then plus b squared. So 7x is ab, doubled is 14x. And then plus b squared, which is 49. All right, Josh, you do the next one. It's x squared minus what? AB is 3x doubled, and then plus. Good. Okay. Now we have to simplify. You get 2x squared. The x terms add up to 20, so minus 20x. The constants add up to 58. And you could have gone ahead and subtracted 16 then, but I took 2 steps. It's kind of a pain. I mean, there's a bit of algebra to do on these. Now, you notice everything in this problem, everything's even. I'm just going to take half of everything, because we have to solve by factoring. That just makes it nicer. And then your factors are 3 and 7. And so you get x equals 3, x equals 7. Before we go further, because we're not done actually, I do want to make one point. If I graphed, just watch, if I graphed this parabola, it would be a parabola that has x-intercepts at 3 and 7. If I graphed the parabola I had before I divided by 2, it had the same x-intercepts. It's just vertically expanded by a factor of 2. I just want you to remember that fact. These parabolas are not the same parabola. I got a different parabola, but with same solutions, same x-intercepts. So that's why you can just divide by 2. It didn't change the solutions. Now, these are not the answers, because what are we trying to find? Yeah, coordinates of points that were where they cross. So when x is 3, what's the y coordinate? Right here, 3 minus 8 gives you negative 5 for the y value? 0. No, it's okay. I don't often get a chance to jab at you. Negative 1 for this one. 7 minus 8 is negative 1. So, which means, by the way, I'm not going to try to draw this exactly, but what we had was a circle with a secant line that intersected at 2 points. What could happen, by the way, if I give you a line and a circle, it could be where you have a circle and a tangent line. That could happen. You could also have no solution. I'm just telling you, that could happen. And so this one, those is kind of a typical case where it just crosses at 2 points, right down the coordinates of both points. All right, I think that was it. Maybe, oh no, these, find these. These shouldn't be too bad, as long as you know what they're talking about. We're going to draw the graph in this one. I'll do the graph and you write the equation. So plot the center, so negative 4, negative 3. Draw the tangent line at y equals 3, it's the horizontal line. And to be tangent to that line means the circle just touches right there, and then just goes around. That's 6 away, by the way, so you know right now the radius is 6. So then go 6 every direction from the center. I put my center in the wrong place, didn't I? Center was supposed to be negative 4, comma 3. That's better. Right, so they're done with the graph. I'll leave it to you to write the equation. They could have said it's tangent to one of the axes. They could have said it's tangent to whatever line they wanted to. Okay, so just know how to draw the picture. It's not hard. Now, number 36 is too easy. I'm just going to forewarn you. They could have a problem like this in the test or on the quiz, where they give you 2 endpoints of the diameter, and you have to do a lot more work in here. So just write these formulas down. Because if you want to write the equation, you need the center and you need the radius, right? Well, if you found the distance between these points, normally you do distance formula to find distance between 2 points. And you should just know distance formula, because it's really just Pythagorean theorem. In reality here, what is the distance between those points? 14, right? So the diameter is 14, the radius is 7 in this problem. But I'm saying normally you need to use distance formula. But one little thing, watch this. If I change, just don't write this down, but if I change it like this, what's the distance? 14. What if I did this? What's the distance? I don't know. You got to use a formula. So be careful about your assumptions, I'm saying. If they're both horizontal, it's easy. If they're both vertical, it's easy. But this is not. You'd have to use the formula. Now, the center. They gave it to you, but usually we don't. Usually I'm just saying, well, we just give you that, and that's all you need. To find the center, given that, you do midpoint formula. And so you would do this x value plus that x value divided by 2. You do the y values averaged. That's midpoint formula. And that's 4 over 2 is 2. That's 0. I'm going to say normally you're not given the center. So know that that's how you'd find it. Okay? And I think that's all I was going to go over. These, I just reiterate, depending on where they put sine and cosine, determines, change the starting point direction.